In Newtonian gravity, if we have two objects of mass m1 and m2, then the force between them is given by g m1 m2, where g is gravitational constant, divided by r square, where r is the distance between the given objects m1 and m2. Now this Newtonian gravity, this formula for the Newtonian gravity requires that both the objects should have non-zero mass, otherwise there will be no force between them. This is the magnitude of the force. We know that photons do not have mass, but if we use mass energy equivalence, which is given by E equals mc square, and also use the formula E is equal to h nu for photons. This comes from quantum mechanics and this comes from special relativity. So on the one hand, energy of a photon is proportional to its frequency, and then mass energy equivalence says that energy is proportional to mass. Using these two equations, we can assign a mass to a photon of frequency nu. If nu is its frequency, then its energy h nu is given by mc square. So its mass, we can assign a mass to the photon, which is given by h nu by c square. So for a photon of frequency nu, we can assign a mass to it given by h nu by c square. Now suppose we have a massive object which is spherically symmetric, and suppose its mass is m, and at a distance r from its center, let us say at a point A, at a distance RA from the center, we have a photon of frequency nu which is moving radially in the outward direction. Suppose its frequency is nu A, and this photon is moving in the radially outward direction. Now at a distance RB from the center, so this point is B, which is at a distance RB from the center, we measure the frequency of this photon, and this frequency suppose is nu B at point B. So this photon at point A was moving in the radially outward direction. We detected it at B, and we found that its frequency is now nu B. It started with frequency nu A, but at point B we detected it and its frequency was nu B. So we can, since this photon is moving in a conservative force field, so energy of this photon at point A and its energy at point B must be same. Energy at point A is, first of all, this photon has energy h nu A, which is its intrinsic energy, and secondly, it has energy, potential energy due to gravitational force, and this potential energy is minus g m, where m is the mass of this spherically symmetric massive object, times the mass of the photon, and mass of the photon at this point A will be h nu A by c square, and this whole thing divided by R A. This will be the potential of this photon at point A. So this total energy at point A must be equal to the energy at point B, which is h nu B minus gm. The potential energy at point B is gm times mass of the photon at B, h nu B by c square, divided by the distance, which is RB. So from this equation, what we take nu A common on the left hand side. If we take h nu A common on the left hand side and h nu B common on the right hand side, we get h will cancel, we'll get nu A 1 minus gm by c square R A equals nu B 1 minus gm by c square RB. Therefore, we will get nu A by nu B equals 1 minus gm by c square RB divided by 1 minus gm by c square RA. If we assume that, let us define by R naught gm 2gm by c square. This is actually Schwarzschild radius. So if we assume that RA is greater than R naught, and we are also assuming that RB is greater than RA, and R naught we are defining as 2gm by c square, and this is Schwarzschild radius. So this will be 1 minus R naught by 2RB 1 minus R naught by 2RA. Since RB is greater than RA, so we will have 1 by RB less than 1 by RA, which implies R naught by 2 RB is less than R naught by 2 RA, which gives minus, if we multiply by minus 1, then this equality will reverse, minus R naught by 2 RB will be greater than minus R naught by 2 RA, and we add 1 on both sides, so we'll get 1 minus R naught by 2 RB greater than 1 minus R naught by 2 RA. So this will imply that this expression 1 minus R naught by 2 RB divided by 1 minus R naught by 2 RA is greater than 1. Because 1 minus R naught by 2 RB is greater than 1 minus R naught by 2 RA. So this becomes greater than 1. So this implies that frequency at A is greater than frequency at B. So the photon has redshifted. Photon is redshifted due to gravity. This prediction of redshifting we have derived from Newtonian gravity, but we have also taken into account two formulas. One mass energy equivalence, which comes from relativity, and another which comes from quantum mechanics, which is E equals h nu. And this conclusion is actually correct, that photon will get redshifted due to gravity, and in the limit when RA and RB very large compared to this Schwarzschild radius 2gm by c square, which we have denoted as R naught in these formulas, this equation is approximately correct. It's a very good approximation in the limit when RA and RB very large compared to R naught. If we look at the exact formula in general relativity, using the Schwarzschild solution, if we derive the exact formula, then the exact formula is nu A by nu B equals square root of 1 minus 2gm by c square RB divided by 1 minus 2gm by c square RA. So the square root is both for numerator as well as denominator. Both numerator and denominator, there's a positive square root. So this is the exact formula. That comes from general theory of relativity. Using Schwarzschild solution. However, one subtle point which needs to be taken into account is that RA and RB in this exact formula are not really distances from the center. They have different interpretation in general relativity. So the interpretation is like this: if we take a spherical surface, 2D surface defined by r equal to RA, this radial coordinate is equal to some constant RA, and time is also constant to some value t naught. Then the 2D surface defined by these two equations will have an area which will be 4 pi RA square. So RA, if we denote this area as A, then RA will be A divided by 4 pi square root. But RA, even though it is related to area A in the expected manner, this relation holds in Euclidean geometry as well, but this RA in Schwarzschild geometry is not the distance from the center, or note the radius of the sphere. By radius I mean it's not the distance from the center. In Schwarzschild geometry. In Newtonian case, this was of course this equation of course holds in Newtonian case, because there we are considering Euclidean geometry, and in that case Ra satisfies this equation, as well as it is distance from the center of this massive object. So these both definitions are equivalent in the Euclidean geometry, but in Schwarzschild space, this Ra is defined as area of the sphere, spherical surface, defined by these two equations, R equal to Ra, T equal to T naught, area divided by 4 pi square root, and Ra satisfies only this equation, and it is not equal to the distance from the center of this massive object. So in the limit when this 2gm by c square is small compared to Ra and R naught, we can take a series expansion of this square root, and in that limit this formula becomes, if we take series expansion of the square root in the numerator as well as in the denominator, this becomes 1 minus 1 half, will cancel 2, so we'll have gm by c square Rb divided by 1 minus gm by c square Ra, and this is same as the formula that we derived in the using the Newtonian gravity. So in the limit when this Schwarzschild radius is small compared to Ra and Rb, this redshift formula derived in general relativity reduces to the formula that we have derived in Newtonian gravity.